Hello, I am Leslie DeChurch, and I am the moderator of our scientific session on understanding and enabling human travel to the moon and Mars. Thank you for joining us. This is one of 3 pre-recorded videos focusing on one speaker's material before all of the panelists come together in February during our live discussion. In this video, Noshir Contractor will be discussing the predictive power of his team's crew composition model and their ability to use the model to anticipate and mitigate relationship problems, repairing crew members onto assigned tasks during a space mission. Midway through this video, Nick Kanas will be joining Noshir to further delve into the material.
Hello. Today I'm going to share with you some of the work that we are doing to help NASA prepare to send teams back into space, first starting with the Artemis mission that will put the first woman and the next man back on the moon, and then on to Mars. As we all know, the humans are on the verge of becoming an interplanetary species, and NASA is at the forefront of trying to help us prepare for that journey to Mars. The journey to Mars is going to be a long one. Because of the way the orbital dynamics work, it's going to take approximately a year or somewhat less than that to get there. And we will have to stay there for about a year before we can again come back so that we are in close proximity to return back to Earth in a timely fashion. Well, one of the things that we've also learned is that based upon the work that has been done by NASA's Human Research Roadmap program, they understand that as we think about long duration space exploration, some of the new challenges that NASA is going to face has to do with teamwork and the fact that keeping people confined for a long period of time without any exit strategy is going to lead to some challenges. In fact, a cosmonaut, Valerie Reumin, said all the conditions necessary for murder are met if you shut 2 men in a cabin measuring 18 by 20 and leave them there together for 2 months. The idea of trying to decide how to put a team together under isolated, confined, extreme environments is not new. If you think back to the times when we were beginning to go first to Antarctica, Sir Ernest Shackleton faced many of the same kinds of issues when he was looking at it. He put this classified ad out that said men wanted for hazardous journey, small wages, bitter, long months of complete darkness, constant danger. And as you can see, that this did not necessarily attract people who were particularly interested in being social. In fact, some of the work that has been shown in that particular case is that places like the Antarctic became a haven for the technically competent individuals who were deficient in social skills. But this early view of selecting for extremes has now been replaced by a future view of selecting for extremes. This was a diary entry that Jack Stuster posted based upon what an astronaut had written in the diary at the International Space Station. Referring to the commander, he's brilliant and knowing the perfect balance of fun with professionalism. This move towards trying to get people who are astronauts and astronaut selection who will in fact be much more socially comfortable, not just in terms of technical competence, was also raised by Peggy Whitson when she was chairing the astronaut selection board in 2009. When she was asked about what kinds of things happen that would be important as they choose astronauts in the future, this is what she said: plays well with others. And in fact, some of the times we've seen that that has worked quite well. For example, astronaut Scott Kelly, when he came back to Earth after one of his longer missions out in space, mentioned that teamwork is what makes the dream work in spaceflight. So our research really is trying to look at what happens to teamwork under extended periods of isolation and confinement. And the roadmap that we followed to do that is listed in this particular flowchart. We started with a conceptual model, then collected some data, estimated the parameters, made sure that our model was valid, and then began to apply the model. So let me take you through these steps very quickly now. The first step was, of course, building that conceptual model. What are the kinds of things that affect crew performance? One of the things we focus a lot is the social relationships amongst the crew members. And the social relationships amongst crew members is affected by 5 buckets of variables that are important. One is the personality of the individuals. The second is the personality fit, the match between the personalities of different people on it. The third year at the bottom refers to the social network relationships. Prior social networks are obviously going to influence future social networks. On the bottom left out here, we see tasks and scheduling. To what extent are the crew relations being affected by the amount of workload they are facing, the amount of interdependence between them in the kinds of tasks they have to do? And then finally, on the top left, we see the contextual factors. To what extent are these relationships being impacted by communication delay? Because as we go farther and farther into space, just because of the laws of physics, it's going to take as much as 21 minutes for a signal to travel from Earth to Mars, for example, and then 21 minutes back. And so as we look at all of these models, we have to obviously identify, based on prior research,